Hello everyone, this is Brainy Ghost, and today we are gonna create a collision response for rectangle versus rectangle collision. So first, this is my constructed collision response. Let's check if this is working. Let's run it. I already compiled this program. Alright, so yeah, as you can see, the yellow rectangle stays at the right edge of this green rectangle, and once I start here and collide here, yeah, and it can go here or here, here or here, and yep, as you can see, this program is working. Now let's reconstruct that program. Alright, let me explain the algorithm first. Before we return back to coding, I expect that you have watched my AABB algorithm, which is part of my points and rectangles collision detection video before watching this video, because I explained some terminologies in rect versus rect video that I won't be explaining here. First off, select a rectangle that is going to be the subject of collision. I'll use R1. Get the centers of both rectangles. Incomplete collision of both rectangles is important here. If R1 only has collision in x-axis, then R1 may be on bottom or top of another rectangle. Let's assign a boolean to hold the incomplete collision state in x-axis, and let's name it the variable xCollide. If R1 only has collision in y-axis, then R1 may be on right or left. Let's assign a boolean to hold the incomplete collision state in y-axis, and let's name the variable yCollide. Now, let's collide R1 to another rectangle, but before we enter to complete collision state, we need to get the incomplete collision state of xCollide and yCollide. Create Boolean variables that will hold xCollide and yCollide values before the two rectangles enter to a complete collision. Let's name them prev xcol and prev ycol. Now let's say they enter to a complete collision. If prev xcol value is true and prev ycol value is false, then R1 may have been on top or bottom of R2. If R1's center is on top of R2's center, then R1 was on the top of R2. Otherwise, R1 was on the bottom of R2. In this case, R1's center is on the bottom of R2. So displace R1 to the bottom of R2. Now, let them collide again. This time, prev xcol value is false and prev ycol is true. Then R1 may have been on right or left of R2. If R1's center is on the right of R2's center, then R1 was on the right of R2. Otherwise, R1 was on the left of R2. In this case, R1's center is on the right, so we displace R1 to the right of R2. Let's say they collide again, but this time prev xcol and prev ycol are false. If that's the case, then R1 was in the no collision zone, if you will, before colliding with R2. This rarely happens. However, this breaks the logic of this algorithm. To resolve this problem, one of many ways that I can think of is to find the overlap of both rectangles in both axes. If overlap x is greater than overlap y, then R1 is probably close to the top or bottom edge of R2. Set prev x call to true and displace R1 to the top or bottom of R2. In this case, R1's center is on top of R2's center, so displace R1 to the top of R2. If overlap y is greater than overlap x, then R1 is close to the right or left edge of R2. Set rev y call value to true and displace R1 to the right or left of R2. In this case, R1's center is on the right of R2's center, so displace R1 to the right of R2. Close this. So get this. You can download this file in the link that I have posted in the description. Let's compile this. No errors. Let's run it. This one is, yeah, it's not complete. As you can see, there's no collision response because, yeah, this is just the code base of my completed collision response that I showed earlier. So now we know this script doesn't have any errors. We can reconstruct this. Alright, so first we have new rectangle here. So R1 is the mouse controlled, R2 is the stationary or the green rectangle that we saw earlier. R1 is, yep, is the yellow, and no, R1 is the mouse controlled, and R3 is going to be the rectangle that will be displaced near the edge, near the edges of the green rectangle. So alright, so check collision, I use AABB here. So first, let's go here. We need to get the previous value of x collide and y collide before they enter to a complete collision state. Wait a minute. So remember this. If the yellow rectangle is here, as you can see, no collision in both axes. Yep, they don't have any collision in both axes. So this is, I would like to call this part a no collision zone. When we are here on top of green, as you can see, x collide is true. Also here, yeah, these zones are the incomplete collision zones, as you can see, and these are the no collision zones. So we need the value of this yellow rectangle, and so we can check if the rectangle, this yellow rectangle is in here, 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 or here. So before they enter, before these two enter to complete collision state where they have collision in both axes, we need to get their value before they enter to a complete collision state. For example, here, this is an R1 is in incomplete collision state. Now enter, and yeah, yellow rectangle is now in a complete collision state with the green rectangle, and both x collide and y collide is true. So we need to get the previous value before they enter to a complete collision state, so we can check if we can check where the previous location of the yellow rectangle is. And yep, all right, so first go here, yep, write this in your code. So first we need to check if x collide and y collide are both false or one of them is false. If both of them are true, then they are in complete collision state. Otherwise, they are in incomplete or no collision state. So we need to get their value when these two are in their no collision or incomplete collision state. Next, go here, get the centers. Yep, center x, center y, R2 center x, center y, and that's done. Next, we need to check the value of prev x call and prev y call, or the previous values of x collide and y collide before they enter to a complete collision state. If prev x collision is true, then write code here. Else if prev y call is true, then write code here. If this is true, it means that the yellow rectangle must be on top or bottom of the green rectangle. If this is true, it means that the yellow rectangle is on the left or right of the green rectangle. So alright, let's code here first and write this in your code. Wait, let me realign this code snippet, and yep, done. So yep, if R1 center y is less than R2, it means that R1 is on top of R2. Then if that's true, then yep, set the R3 right position and width and height, for width 40, height 40, same as R2, and the position is important here. So when this is true, it means that the yellow rectangle is on top or bottom of the green rectangle, so we don't need to change the x value, we just wanted to change the y to displace R3 to the top or bottom, depends on the center position position of R1 and R2. So in this case, let's just say that R1 is on top. So yeah, move it. You need to displace R3 to the top of R2 or the green rectangle. So to do that, get the value of R2 and yep, reduce reduce and minus it to the height of R1. If R1 is greater than R2, then yeah, R1 is on the bottom of R2. So we need to move R3 to the bottom part of the green rectangle. So to do that, get the original y value of R2 and yep, add its height to its position. So R3 will respond on the bottom part of R2. And yep, we can try this now. So let's check. Alright, no errors. Yeah, this collision here won't work because we don't have code yeah right now. So here, let's try here. And as you can see, it's working here. Very cool. Yep. Now we have collision response on top and bottom of this green rectangle. Now let's go the collision response for the left and right. So here, write this in your code. So yep, same, very similar to this code snippet. This code snippet is very similar to this. So let me explain this. So if this true, it means that R1 is on the left or right side of R2. So we don't need to move the Y position of R3. So if R1 center X is less than R2 center X, it means that R1 is on the left side of R2. So we want to displace R3 to the left side of R2. To do that, get its original position and then minus it to R1 with. Now next, if this is greater than R2, then R1 is on the right side of R2. So we want R3 to be displaced on the right side of R2. So to do that, get its original position and add its width. And now we can try if this is working. And yep, it's working. So we have a collision response in the y-axis, no, in the left and right side of this green rectangle, and also here, top and bottom. Now, how about, for example, this rectangle is here, then it collided here. As you can see, when, yeah, wait. So for example, we're here, both x collide and y collide are false, then it suddenly collided with the green rectangle. As you can see, in here, yep, our collision is still working, but sometimes it, yeah, both x collide and y collide before they enter to a complete collision state might be both false. We don't want that to happen because yep, it breaks the logic of this algorithm because you just process the position of rectangle here, 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 and here, and we don't process the position. Our algorithm does not process a collision between a no collision state and a complete collision. So it breaks the logic. But there's a way that I can think of. So let's code. So write this in your code. If both of them are false, yep, it means that the yellow rectangle started from the no collision zone, then collided with the green rectangle. So let's process that. So yep, first get the average width and height of both rectangles and get the distance x or the x distance between two centers. Next, get the distance y or the y distance between centers. And after that, get the overlap. So overlap x, get it, and overlap y. Once that's done, compare the overlap. If overlap x is greater than y, then it means that the yellow rectangle is probably on top or bottom of the green rectangle. Yep. So set this to true, and once this done, the program will process the displacement of R3. So if this is true, then yeah, this statement will be processed and move the R3 to the top or bottom depending on the position of their centers. If x is less than y, then R1 is probably close to the right or left of R2. So set this to true, the prev call y. Then once program is done here, yeah, the program will process this. Yeah, having the values of these two booleans to be false at the same time before entering a complete collision state rarely happens. Yep, so this phenomena kinda hard to reproduce, but we can it can also happen when both rectangles collide initially. Yep. So for example, like no. All right. Wait. So the GUI will spawn here. I need to time it right. Yeah, as you can see, we don't have R3 here because it initially happens. Yeah, this is the phenomena that I was saying. Yeah, it's easy to reproduce if both rectangles collide initially, but yeah, reproducing that phenomena here is hard. For example, you want to collide it here. As you can see, it's hard to reproduce when we want to collide the yellow rectangle starting from the no collision zone to the complete collision state. Yeah, it's hard. So now let's compile this and see if this code, yeah, this code is working. So let's check. No. Okay, this it will respond here. Time it right. Wait a minute. Uh, I think, yeah, I put the wrong variables here. Yeah, I want to get the previous, not the current. So previous x call and previous y call. Yeah, this should work. Open this, then compile and run. And yeah, I need to time my positioning here. Yeah, position my mouse here before the GUI appears. Check. And yeah, as you can see, it's working. And that's all for this tutorial. I hope you've learned something from this. Going to end the video here and see you later.